Have you ever wondered if we're not the first intelligent beings in our solar system? What if right next door, on a planet we can see shining in our night sky, entire civilizations rose and fell billions of years before humans even existed? What if Venus, that brilliant morning star our ancestors worshipped, once hosted cities, cultures, and technologies that vanished without a trace? Tonight, we're diving into one of the most mind-bending possibilities in planetary science, a theory that flips everything we think we know about life in our cosmic neighborhood completely upside down. Because what if Earth isn't special? What if we're actually the second chapter in a story that began long ago on a world now shrouded in toxic clouds and crushing heat? I'm talking about Venus, that gleaming jewel in our sky that's actually a hellscape where lead melts like butter and the air pressure would crush you instantly. But here's the kicker. It wasn't always this way, and the evidence suggests something absolutely extraordinary might have happened there before our planet was even ready for life. By the end of this series, you'll understand why some scientists are seriously considering whether Venus could have been home to advanced civilizations millions of years before Earth's first cities. We'll explore how these hypothetical beings might have lived, what their world looked like, and most importantly, what happened to them. This isn't science fiction. This is cutting-edge planetary science that's forcing us to completely rethink our place in the universe. But first, let me blow your mind with just how similar Venus and Earth actually are. We call them twin planets for a reason, and once you understand the parallels, the possibility of ancient Venusian civilizations becomes a lot less crazy than you might think. Picture this. Venus is almost exactly the same size as Earth. I'm talking about a difference of less than 400 miles in diameter. Their masses are nearly identical too, which means if you could somehow survive on Venus's surface, you'd weigh almost exactly the same as you do here on Earth. Both planets form from the same cosmic materials in the same stellar nursery around the same young sun. They're both rocky worlds with dense atmospheres, and they both sit in what astronomers call the inner solar system, that sweet spot where planets can actually receive enough energy from the sun to potentially support liquid water. On paper, Venus looks like it should be Earth's paradise twin. But something went catastrophically wrong. Today, Venus is the definition of a planetary nightmare. The surface temperature hovers around 900 degrees Fahrenheit, hot enough to melt lead, zinc, and tin. The atmospheric pressure is 90 times greater than what we experience at sea level, equivalent to being crushed under 3,000 feet of ocean water. The clouds aren't made of water vapor like ours, but of concentrated sulfuric acid that would dissolve you in seconds. The Soviet Union learned this the hard way back in the 70s and 80s when they sent multiple probes to Venus's surface. These weren't cheap missions. Each probe was built like a tank, designed to withstand extreme conditions. The longest any of them survived on the surface was just over 2 hours before the electronics failed completely. The images they managed to transmit back showed a landscape of endless rocky plains under a sickly yellow sky, looking like something from humanity's worst nightmares about hell. For decades, Scientists looked at this data and concluded that Venus had always been hostile to life. It seemed like Earth's evil twin, similar in size and composition, but fundamentally different in every way that mattered for biology. Case closed, right? Wrong. Dead wrong. Because here's where the story gets absolutely fascinating. Over the past few decades, as our computer models have gotten more sophisticated and our understanding of planetary climates has deepened, a completely different picture of Venus's past has started to emerge. And it's a picture that changes everything we thought we knew about the potential for life in our solar system. Modern climate simulations are showing us something remarkable. When researchers model Venus with different atmospheric conditions, thinner clouds, lower carbon dioxide levels, more moderate temperatures, the results are stunning. The planet cools down enough to support liquid water on its surface, not just puddles or small lakes, but vast shallow oceans covering significant portions of the planet. These aren't wild guesses or wishful thinking. These are sophisticated models based on our understanding of planetary physics, atmospheric chemistry, and climate dynamics. And they consistently suggest that Venus could have remained stable and Earth-like for hundreds of millions of years. Some models stretch that window to nearly 2 billion years, an almost incomprehensible span of time that would have given life not just a chance to appear, but to evolve, diversify, and potentially reach incredible levels of complexity. But the evidence goes beyond computer models. The European Space Agency's Venus Express mission, which studied the planet from orbit for 8 years, gathered data that hints at Venus's watery past. By measuring the ratios of different hydrogen isotopes in the planet's atmosphere, scientists found chemical fingerprints suggesting that enormous quantities of water were lost to space over geological time. Think about what that means. Today, Venus's atmosphere is bone dry. There's almost no water vapor at all. But the isotope ratios tell a story of massive water loss, the kind that would happen if entire oceans slowly evaporated and escaped into space over millions of years. Venus didn't start dry. It became dry. This is where the speculation gets really interesting, because if Venus once had oceans, then it had the most important ingredient for life, as we know it. And if those oceans lasted for hundreds of millions of years, then life would have had time to do what life does best: evolve, adapt, and become more complex. On Earth, simple microbes appeared within the first billion years after our planet's formation. If Venus reached stability earlier than Earth did, and there's good reason to think it might have, then life there could have had a massive head start. While Earth was still getting pummeled by asteroids and struggling to maintain stable conditions, Venus might already have been nurturing the first living organisms in relatively calm, protected seas. Here's the mind-bending part. Evolution is slow, but time is the fuel that drives it. A planet that gets life started earlier has more opportunities for that life to become complex. On Earth, it took billions of years for single-celled organisms to give rise to multicellular life. But that process wasn't inevitable. It required stable conditions lasting long enough for those evolutionary leaps to occur. If Venus offered that kind of stability, then the possibility emerges that complexity began there first. Microscopic life could have formed colonies, specialized into different roles, and eventually created the first multicellular organisms. From there, the steps toward larger, more complex beings become less unthinkable. And if evolution had more time to work on Venus, if that planet provided stable oceans and energy sources for hundreds of millions of years longer than Earth, then we have to ask the ultimate question: could intelligence have emerged there first? Could Venus have been home to the solar system's first civilizations? This isn't just about microbes or simple plants. We're talking about the possibility that while Earth was still a hostile volcanic wasteland, Venus might have been bustling with complex ecosystems, maybe even with beings capable of building cities, developing technology, and creating cultures that lasted for millions of years. The implications are staggering. If this is true, then Earth isn't the first chapter in the story of life and intelligence in our solar system. We're the sequel. Venus would have been the original, the proof of concept that planets can give rise to civilizations. And somehow, that entire world and everything it achieved vanished so completely that we're only now beginning to piece together clues that it might have existed at all. But how could an entire planet's worth of civilizations disappear without a trace? What could have happened to transform a world of oceans and potentially cities into the acid-shrouded hellscape we see today? And if Venus really was home to ancient civilizations, what does that mean for our understanding of life, intelligence, and our own future in the universe? These are the questions we'll be exploring in the next part of this series, because the story of Venus's transformation from potential paradise to planetary hell is one of the most dramatic climate shifts imaginable. It's a cautionary tale written in the rocks and atmosphere of our closest planetary neighbor, and it has profound implications for every world that has ever hosted life. The story of what happened to Venus reads like the ultimate cautionary tale about planetary climate systems gone wrong. But to understand how an entire world could transform from a potential cradle of civilization into the furnace we see today, we need to dive deep into the mechanics of planetary death. What destroyed Venus wasn't war, asteroid impact, or some cosmic catastrophe. It was something far more insidious and terrifying. A runaway greenhouse effect that slowly strangled the planet over millions of years. And the scariest part? Once this process began, there was absolutely no way to stop it. Here's how planetary murder works. The greenhouse effect itself isn't evil. In fact, it's what keeps Earth warm enough for life to exist. Certain gases in our atmosphere, like carbon dioxide and water vapor, trap heat from the sun and prevent it from escaping back into space. Without this natural blanket, our planet would be a frozen wasteland. But like many things in nature, it's all about balance. Too little greenhouse effect, and you freeze. Too much, and you cook. Venus crossed that line of no return, and when it did, physics took over with ruthless efficiency. As the planet began warming, more water started evaporating from its oceans. Now, here's the cruel twist. Water vapor is itself a powerful greenhouse gas. So as more water entered the atmosphere, it trapped even more heat, which caused even more water to evaporate, which trapped even more heat. You see where this is going. This feedback loop became a death spiral that fed on itself with increasing intensity. The oceans that might once have supported Venusian life literally boiled away into the atmosphere. But the nightmare was just beginning. Once all that water vapor was floating in the sky, ultraviolet radiation from the sun began breaking it apart at the molecular level. The hydrogen, being light, escaped into space forever. The oxygen either reacted with surface rocks or combined with other atmospheric gases. Meanwhile, with no more oceans to absorb carbon dioxide from volcanic eruptions, CO2 levels skyrocketed to concentrations hundreds of times greater than Earth's. The atmosphere became a suffocating blanket of heat that no force in the universe could lift. Venus had crossed a threshold from which there was no return. But here's what makes this story even more haunting when we consider the possibility of ancient civilizations. This transformation didn't happen overnight. Climate models suggest the runaway greenhouse effect unfolded over thousands, possibly millions of years, long enough for any inhabitants to watch their world slowly dying around them. Imagine being part of a civilization witnessing this planetary apocalypse in slow motion. The early signs would have been subtle. Perhaps coastal cities, noticing that high tides were getting slightly higher each century, then gradually lower as the seas began their retreat. Rivers that had flowed for millennia would start running shallow, then dry up entirely. Lakes essential for agriculture and drinking water would shrink into cracked basins of hardened mud. At first, these changes might have seemed manageable. Civilizations adapt, after all. They could have migrated toward remaining water sources, built more sophisticated reservoirs, or developed new technologies for water conservation. But as each generation passed, the crisis would have deepened beyond any technological solution. The atmosphere itself would have grown heavier and more oppressive. Breathing would have become increasingly difficult as air pressure mounted and the chemical composition shifted. Crops would have failed as temperatures rose beyond their tolerance levels. Animal populations would have collapsed, eliminating crucial food sources. Entire ecosystems would have unraveled as the fundamental conditions for life slipped away. Any Venusian civilizations would have faced migration on an unprecedented scale, with entire populations forced to abandon their ancestral homelands in search of regions where life could still cling to existence. But this wouldn't have been migration to greener pastures. It would have been a desperate retreat to the last habitable zones on a dying planet. The psychological impact would have been devastating. These beings would have possessed cultural memories of a time when their world was lush and hospitable. Stories passed down through generations would speak of great cities by the sea, of fertile valleys, and abundant harvests. But with each passing era, those stories would have seemed more like impossible fairy tales, as the reality outside grew harsher and more alien. Some might have turned to technology in increasingly desperate attempts to fight the changes. Perhaps they developed more efficient methods of water extraction and storage, or built sealed habitats designed to maintain livable conditions. They might have even attempted massive geoengineering projects, trying to redirect volcanic activity or seed the atmosphere with particles to block sunlight. But the scale of Venus's transformation would have overwhelmed any conceivable technology. You can't engineer your way out of boiling oceans and an atmosphere turning toxic. The planet itself was shifting into a new state that no form of life could survive. In the final stages, survival would have narrowed to increasingly small refuges. Entire civilization that might once have spanned continents would have been reduced to scattered communities, clustered around the last sources of water. These final outposts would have been living museums of a dying world, preserving whatever knowledge and culture they could, while watching their planet transform into something unrecognizable. The end, when it came, would have been absolute. Once the oceans were gone, no amount of adaptation or technology could have prevented extinction. The last Venusian beings would have witnessed something no civilization should ever have to see: the complete death of their world. But here's where this story takes an even more intriguing turn. What if some of these hypothetical civilizations saw the writing on the wall? What if they realized their planet was doomed and attempted something that seems almost impossible? Escape to another world. The idea sounds like science fiction, but consider the timeline we're dealing with. If Venus really did have hundreds of millions of years of habitability, and if evolution there had a head start on Earth, then any civilizations that arose might have had vastly more time to develop advanced technologies than humans have had. On Earth, we went from the first powered flight to landing on the moon in just 66 years. We developed rocket technology capable of interplanetary travel within a single human lifetime. Imagine what a civilization might accomplish with millions of additional years to experiment, innovate, and push the boundaries of what's possible. Facing planetary extinction, the development of space travel wouldn't have been driven by curiosity or exploration. It would have been the ultimate survival imperative, and the destination would have been obvious. Just one planet away, Earth would have been visible as a smaller world in their sky, though hidden from direct observation by Venus's increasingly thick clouds. The challenges would have been immense. Venus has higher gravity than Mars, making escape more difficult. The thick atmosphere would have created both opportunities and obstacles for flight, easier to achieve lift with lighter-than-air craft, but incredibly difficult to break through the dense, corrosive cloud layers to reach space. Yet, civilizations with sufficient time might have found ways to overcome these obstacles. They might have started with balloons or gliders, gradually exploring the upper layers of their atmosphere where conditions were less extreme. From there, they could have developed propulsion systems specifically adapted to their world's unique environment. The journey to Earth would have been treacherous beyond imagination. Any beings attempting this crossing would have been leaving behind everything they had ever known: their cultures, their histories, their ancestral homes, for an uncertain future on a young and largely unknown world. But what would they have found when they arrived? Early Earth was no paradise. It was still a volatile, dangerous place full of volcanic activity, unstable weather patterns, and a biosphere just beginning to take shape. For refugees from a dying world, though, it might have represented hope. a second chance for life to continue somewhere new. This brings us to one of the most fascinating aspects of the Venus hypothesis. If civilizations really did exist there, and if some of their people, or at least their biological legacy, somehow reached Earth, then our planet's story becomes far more complex and interconnected than we ever imagined. The concept of life traveling between planets isn't just wild speculation. It's actually a well-established scientific theory called panspermia. And when we apply this idea to Venus and Earth, the implications become absolutely mind-blowing. Here's what we know for certain. Rocks can and do travel between planets. We found meteorites on Earth that originated on Mars, identified by their unique chemical signatures. If chunks of the red planet can make the journey to our world, then it's entirely reasonable that material could also travel from Venus to Earth, even though the process would be more complex due to Venus's thick atmosphere. During the early solar system, massive asteroid and comet impacts were far more common than they are today. When these cosmic projectiles slammed into planets with tremendous force, they didn't just create craters. They launched debris into space at incredible velocities. Some of this ejected material, carrying microscopic passengers, could have made the journey between worlds. Now imagine this. If Venus really did host thriving ecosystems for hundreds of millions of years, then some of those ancient impact events might have launched rocks containing Venusian microbes toward Earth. These tiny time capsules could have carried the seeds of life from a dying world to a young planet just beginning to develop conditions suitable for biology. This isn't just theoretical anymore. Scientists have demonstrated that certain microorganisms can survive the harsh conditions of space travel. The vacuum, radiation, and extreme temperatures that would characterize such a journey. If life could make this incredible voyage, then Earth's first biological stirrings might not have originated here at all. They could be the legacy of Venus, carrying forward the genetic heritage of our planetary neighbor. But panspermia opens up an even more speculative possibility. What if the transfer of life between Venus and Earth wasn't just accidental? What if advanced Venusian civilizations, recognizing their planet's inevitable doom, deliberately attempted to preserve their biological legacy by sending it to Earth? Picture this scenario. A civilization watching their world slowly transform into a hellscape realizes they cannot save themselves, but they might be able to save something. Perhaps they understood enough about biology and space travel to engineer organisms specifically designed to survive interplanetary journeys. Maybe they launched carefully designed capsules containing not just microbes, but complex genetic information intended to seed life on Earth. In this framework, every living thing on our planet could carry within its DNA the faint echo of another world. The genetic code that defines all earthly life might not be purely terrestrial in origin, but rather a continuation of biological experiments that began billions of years ago under alien skies. This idea transforms how we think about human origins and our place in the cosmic story. We often imagine ourselves as the unique product of Earth's evolution, the culmination of billions of years of natural selection on this specific world. But if the Venus hypothesis is correct, then we might be part of a much longer chain of life that stretches back to conditions and environments we can barely imagine. The implications ripple outward in fascinating directions. Throughout human history, cultures around the world have told remarkably similar stories about beings who came from the sky, bringing knowledge and wisdom to early societies. From Mesopotamian tales of divine teachers to Mesoamerican legends of gods descending from the heavens, these myths share common themes that have puzzled anthropologists for generations. Usually, we interpret these stories as symbolic expressions of human imagination and spiritual longing. But within the context of the Venus hypothesis, they take on a different dimension. What if some of these ancient accounts preserve distorted memories of actual encounters? What if refugees from Venus arriving on Earth during humanity's early development left such a profound impression that the memory survived in mythological form for thousands of years? Consider how such visitors would have appeared to early human societies. They would have possessed knowledge and technologies developed over millions of years of evolution and civilization. Their understanding of astronomy, despite their cloud-covered skies, would have been profound out of necessity. Their engineering capabilities, honed by the challenge of surviving on an increasingly hostile world, would have seemed miraculous to hunter-gatherer societies just beginning to develop agriculture and permanent settlements. These beings wouldn't have seemed like travelers from another world. They would have seemed like gods. Their arrival would have been the kind of transformative event that gets woven into the foundational stories of entire cultures. But here's where the mystery deepens even further. If Venus really did seed Earth with life, or if actual Venusian refugees somehow reached our world, what evidence might remain? After billions of years of geological activity, continental drift, and atmospheric change, could any traces of such an ancient connection still exist? The answer is both frustrating and intriguing. Maybe, but they would be incredibly difficult to detect. Earth is a dynamic planet that constantly recycles its surface materials. Unlike Mars or the Moon, where ancient surfaces can be preserved for billions of years, our world efficiently erases its own history through plate tectonics, weathering, and biological processes. Any physical structures or artifacts left by hypothetical Venusian visitors would have been ground to dust and reformed countless times. Their tools would have corroded, their buildings crumbled, their cities buried under miles of sediment and new rock. Time itself would have eliminated virtually any direct evidence of their presence, yet subtle traces might linger in unexpected places. The genetic code of life on Earth, while appearing uniform across all organisms, might contain hidden signatures that point to extraterrestrial origins. Unusual isotope ratios in ancient rock formations could hint at processes or materials that don't quite fit standard models of Earth's early development. Cultural evidence presents another intriguing avenue for investigation. While individual myths and legends can't prove anything by themselves, the persistence of certain themes across widely separated human societies is striking. the recurring motif of skyborn teachers, the widespread association of Venus with both divine wisdom and mysterious danger, the uncanny similarities between astronomical knowledge developed by cultures that had no contact with each other, these patterns might reflect something deeper than coincidence. Archaeological anomalies also deserve consideration. Throughout history, excavations have uncovered artifacts, structures, and evidence of technologies that seem to appear suddenly in the archaeological record without clear developmental precursors. While mainstream archaeology has explanations for most of these findings, the Venus hypothesis provides an alternative framework for understanding why certain innovations might have appeared more rapidly or completely than gradual development would predict. The biological evidence is perhaps most intriguing of all. Life on Earth shares a common genetic foundation, the same basic DNA and RNA structures, the same fundamental biochemical processes. This universality strongly suggests a single origin for all terrestrial biology. But that origin could have occurred here on Earth, or it could have arrived from elsewhere, already carrying the unified genetic framework we observe today. Recent discoveries in extremophile research, the study of organisms that thrive in conditions previously thought uninhabitable, have shown that life is far more resilient and adaptable than we once believed. Microorganisms have been found surviving in environments that mimic the harsh conditions of space travel. These findings make interplanetary panspermia not just possible, but increasingly plausible. What makes the Venus connection especially compelling is the timeline. If Venus maintained habitable conditions for hundreds of millions of years before Earth was ready for complex life, then any biological transfer would have occurred during the perfect window, after Venusian life had time to evolve and diversify. But before Earth's own ecosystems became too established to integrate foreign organisms. This temporal overlap creates a scenario where Venus could have served as life's nursery for our entire solar system, developing and refining the biological processes that would later take root and flourish on Earth. In this view, our planet becomes not the origin point of life, but rather its second home, a refuge world that carried forward the evolutionary legacy of a dying planet. The philosophical implications of this possibility are profound. It suggests that life in our solar system might be more interconnected and ancient than we ever suspected. Rather than being isolated accidents occurring independently on different worlds, the emergence of life on Earth and potentially other planets could be part of a single, extended story that began billions of years ago, under very different circumstances. If true, this would fundamentally change how we think about our cosmic significance. We wouldn't be alone in the universe, because we never were alone. We would be the continuation of a story that began elsewhere, carrying forward not just biological heritage, but potentially the cultural and intellectual legacy of civilizations that faced and survived challenges we can barely comprehend. But perhaps most importantly, the Venus hypothesis offers us a mirror for understanding our own future. If advanced civilizations really did exist on Venus, and if they ultimately failed to prevent their world's transformation into a hellscape, What does that tell us about the fragility of planetary habitability? What lessons might their story hold for Earth as we face our own environmental challenges? The answer to these questions don't just satisfy curiosity about ancient mysteries. They could be crucial for understanding how to protect the only world we know for certain can support human civilization. These aren't just abstract philosophical questions anymore. They're urgent practical concerns that could determine whether human civilization survives the next few centuries. Because when we study Venus's climate catastrophe in detail, the parallels to Earth's current situation become genuinely unsettling. Think about it this way. Venus shows us what happens when a planet's climate system goes into runaway mode. The greenhouse gases build up, temperatures soar, and feedback loops create an unstoppable spiral toward planetary death. Sound familiar? We're pumping carbon dioxide into Earth's atmosphere at unprecedented rates. And we're already seeing the early warning signs of climate instability. Now, I'm not saying Earth is doomed to become Venus. Our planet has several advantages that Venus lacked. We're farther from the sun, so we receive less intense solar radiation. We have a large moon that stabilizes our climate. Our plate tectonic system helps regulate atmospheric chemistry over geological timescales. These factors give us more resilience against runaway greenhouse effects. But here's what should terrify us. Venus's transformation shows that planetary climate systems have tipping points, cross certain thresholds, and there's no going back. The physics becomes relentless and irreversible. If hypothetical Venusian civilizations really did exist, they learned this lesson the hard way. Their world crossed that line of no return, and no amount of advanced technology could save them. This brings us to one of the most chilling aspects of the Venus hypothesis. If these ancient civilizations really existed, they might have been far more technologically sophisticated than us. They potentially had millions of years longer to develop solutions to environmental crises. Yet they still couldn't prevent their planet's death. What does that tell us about the ultimate limits of technology when faced with planetary-scale climate breakdown? Maybe there really are some problems that no amount of engineering can solve. Maybe once you trigger certain feedback loops in a planet's climate system, physics takes over and intelligence becomes irrelevant. But let's explore what these hypothetical Venusian civilizations might have actually looked like during their golden age, before the climate apocalypse began. Because if we're going to seriously consider this possibility, we need to imagine how intelligent beings might have adapted to Venus's unique environment during its habitable period. Picture ancient Venus during its ocean phase. The planet would have been dramatically different from Earth, even in its prime. The thick atmosphere that eventually became Venus's death shroud might initially have been a blessing. Dense air provides excellent insulation against temperature swings and offers superior protection from harmful space radiation. The constant cloud cover would have created a world of eternal twilight. No blazing sun overhead, no star-filled nights, just a soft, diffused glow filtering down through layers of water vapor. This would have profoundly shaped how Venusian life evolved and how any resulting civilizations developed their understanding of the universe. On Earth, Astronomy drove early science because people could see the stars and track celestial movements. Venusian civilizations would have been completely cut off from direct observation of the cosmos. Their sky was a blank canvas, revealing nothing about the universe beyond their atmospheric cocoon. This isolation would have forced their intellectual development along completely different paths. Instead of looking outward to the stars for navigation and timekeeping, they would have turned inward to their planet's own rhythms. The slow rotation of Venus, where a single day lasts longer than a Venusian year, would have created unique challenges for any beings trying to organize society around natural cycles. Without clear day-night divisions, their concepts of time might have been based on atmospheric patterns, tidal movements, or volcanic activity. Their calendars could have tracked the subtle shifts in cloud density or the periodic warming and cooling of geothermal regions. Their entire cultural relationship with time would have been alien to anything we understand. The geography of Venus would have shaped these civilizations in fascinating ways. Radar mapping has revealed that Venus has massive highland plateaus comparable to Earth's continents. During the ocean period, these elevated regions would have been islands or perhaps large land masses surrounded by shallow seas. Imagine sprawling civilizations built along the coastlines of these ancient Venusian continents. Their cities might have been architectural marvels adapted to the planet's unique conditions, structures designed to handle high humidity, frequent volcanic activity, and the constant gentle warmth of their greenhouse world. The building materials would have been primarily volcanic rock, which was abundant across the planet's surface. But unlike Earth's stone architecture, Venusian construction would have been adapted to a world without freeze-thaw cycles or dramatic temperature variations. Their buildings could have been more organic, flowing forms that worked with the planet's geological rhythms rather than fighting against them. Water management would have been central to their urban planning, but not because water was scarce, because it was everywhere. High evaporation rates in the warm climate would have required sophisticated systems for collecting, storing, and distributing moisture. Their cities might have featured elaborate networks of channels, reservoirs, and atmospheric water collectors that turned the abundant humidity into usable resources. The energy sources available to Venusian civilizations would have been remarkably diverse. Geothermal power from the planet's active volcanism would have provided a constant, reliable energy source. The thick atmosphere would have made wind power incredibly efficient. Dense air carries more energy than thin air, so their wind turbines could have generated enormous amounts of electricity. Solar power would have worked differently than on Earth. The constant cloud cover would have created diffused but steady illumination across the entire planet. No dramatic day-night cycles, no seasonal variations, just consistent, gentle energy input that could be harvested continuously. But perhaps most intriguingly, the dense atmosphere itself could have been an energy source. The constant circulation of heavy air around the planet would have created opportunities for atmospheric energy harvesting that we can barely imagine. Venusian engineers might have developed technologies that captured energy directly from air pressure differentials or atmospheric electrical phenomena. Their transportation systems would have been unlike anything on Earth. The thick atmosphere would have made lighter than air travel incredibly efficient. Imagine vast airships floating through the perpetual twilight, carrying goods and people between the scattered island continents. These wouldn't have been the fragile balloons we associate with early aviation. They would have been robust, ocean-going vessels of the sky. Water travel would have been equally important, but adapted to very different conditions than Earth's oceans. Venusian seas might have been shallower and warmer than ours, with different chemical compositions due to the planet's volcanic activity. Their ships would have been designed for these unique conditions, possibly incorporating materials and techniques that could handle the higher mineral content and temperature of their waters. The absence of visible stars would have created fascinating challenges for navigation. Without celestial reference points, Venusian navigators would have had to develop alternative methods. They might have used magnetic navigation, tracking the planet's magnetic field patterns. Or they could have relied on atmospheric cues, subtle variations in air pressure, humidity, or chemical composition that indicated geographic location. Their maps wouldn't have been based on astronomical coordinates, but on local landmarks and environmental features. Mountain ranges, volcanic regions, and ocean currents would have been their primary reference points. This would have created a very different relationship with geography, more intimate and immediate than our satellite-guided understanding of Earth's surface. Communication across these scattered civilizations would have presented unique opportunities. Sound travels much more efficiently through dense air than thin air. Venusian societies might have developed sophisticated acoustic communication systems that could send messages across vast distances using the planet's atmospheric properties. Imagine networks of acoustic relay stations positioned on mountaintops and coastal cliffs, amplifying and redirecting sound signals across the planet. Their languages might have evolved to take advantage of these acoustic properties, incorporating tonal variations and harmonic structures that wouldn't work in Earth's thinner atmosphere. The cultural implications of living under perpetual clouds would have been profound. Without visible stars to inspire myths about cosmic forces and divine beings dwelling in the heavens, Venusian mythologies would have focused on earthbound powers. Volcanoes might have been seen as the dwelling places of gods. The mysterious forces that created weather patterns in their cloud-shrouded sky could have been personified as atmospheric deities. Their art and architecture would have reflected this inward focus. Instead of reaching toward the stars, their monuments might have been designed to harmonize with geological forces. Temples built around geothermal vents, cities that incorporated volcanic activity as functional and spiritual elements, artistic traditions that celebrated the interplay between land, sea, and the ever-present clouds above. But perhaps most fascinating of all would have been their scientific development. Cut off from direct observation of the broader universe, Venusian scientists would have become incredible experts on planetary systems. Their geology, chemistry, and atmospheric sciences might have advanced far beyond anything we've achieved, driven by the need to understand and work with their world's complex environmental systems. They might have developed technologies for predicting volcanic eruptions with incredible precision, or engineered biological systems that could thrive in high temperature, high humidity environments. Their understanding of atmospheric dynamics could have been so advanced that they could manipulate local weather patterns or even influence the planet's global circulation systems. This mastery of planetary sciences becomes especially poignant when we consider what happened next. These hypothetical beings, with their deep understanding of how planets work, would have been among the first to recognize the signs that their world was beginning its transformation toward uninhabitability. They would have seen the early indicators that modern climate scientists look for: rising atmospheric carbon dioxide levels, increasing ocean temperatures, changes in weather patterns that signaled the beginning of feedback loops. Unlike us, they wouldn't have had the luxury of debating whether the changes were natural or artificial. They would have understood with terrifying clarity that their planet was entering a death spiral. This knowledge would have created an unprecedented crisis for their civilizations. Imagine being part of a society that understands exactly how and why their world is dying, but lacks the power to stop it. The psychological impact would have been devastating. Entire cultures forced to confront the reality that everything they had built was temporary, that their planet itself had an expiration date. Some might have retreated into denial or fatalism. Others could have thrown themselves into desperate technological projects, trying to engineer solutions to planetary scale problems. The most forward-thinking might have begun the ultimate contingency planning, preparing for the possibility that their species would need to find a new home among the stars. This scenario brings us to one of the most speculative but fascinating aspects of the Venus hypothesis. If these civilizations really existed, and if they really did develop advanced space travel capabilities in response to their planet's dying, then Earth might not just be the recipient of Venusian microbes carried by natural panspermia. We might be the recipients of a deliberate rescue mission. Think about this for a moment. If you were part of a dying civilization watching your world slowly transform into a hellscape, what would be your ultimate priority? Saving your technology, preserving your culture, or ensuring that life itself somehow continues, even if it means starting over on a completely different world? The most compelling aspect of the Venus escape hypothesis isn't just that they might have tried to leave. It's that Earth would have been the obvious destination. From Venus, our planet would have appeared as a promising young world just entering its habitable phase. While Venus was losing its oceans to runaway greenhouse effects, Earth was developing the stable climate systems that would eventually support billions of years of evolution. But here's where this story becomes absolutely mind-blowing. The timeline works almost too perfectly. Computer models suggest that Venus could have maintained habitable conditions for up to 2 billion years before the greenhouse apocalypse began. Earth's earliest signs of life appear in rocks dating back roughly 3.5 billion years ago. If Venus started its decline around the same time Earth was becoming truly habitable, then any Venusian escape attempts would have coincided perfectly with our planet's readiness to receive them. Now, imagine you're a Venusian scientist watching your planet die. You understand atmospheric chemistry better than anyone in your civilization's history because you've had to. You know that your world has maybe a few million years left before conditions become completely uninhabitable. And you're looking at this nearby planet that's showing all the signs of entering the stable phase your world is leaving. The technology needed for such a journey would have been staggering. But remember, these hypothetical civilizations had geological time scales to develop it. Humans went from the Wright Flyer to the International Space Station in just over a century. What could a species accomplish with millions of additional years? And the ultimate motivation, planetary extinction. They wouldn't have needed to transport entire populations. Even a small number of successful missions carrying genetic material, embryos, or even living refugees could have fundamentally altered Earth's developmental trajectory. A handful of advanced beings arriving on early Earth would have been like time travelers, carrying knowledge and capabilities that wouldn't naturally emerge here for millions of years. But let's think about what kind of beings these might have been. Evolution on Venus would have followed completely different paths than on Earth. The constant warmth, high humidity, and dense atmosphere would have shaped life in ways we can barely imagine. Venusian organisms might have been adapted to extract moisture directly from the air, to thrive in low-light conditions, and to handle atmospheric pressures that would crush most Earth life. Their intelligence might have been fundamentally different from ours, too. Without visible stars to inspire abstract mathematical thinking about cosmic distances and celestial mechanics, their minds could have been incredibly sophisticated in other areas. They might have been masters of chemistry, understanding molecular interactions at levels we're only beginning to approach. Their pattern recognition abilities could have been extraordinary, evolved to navigate a world where subtle atmospheric and geological cues were the only reliable guides. These differences would have made them seem almost magical to any early Earth life forms they encountered. Their understanding of chemistry could have appeared as alchemy. Their ability to predict weather patterns or geological events would have seemed like prophecy. Their technologies, evolved over millions of years of dealing with a challenging environment, would have been utterly incomprehensible to primitive Earth ecosystem. This is where the ancient astronaut theories start to make a different kind of sense. Not as visits from distant star systems, but as refugees from the planet next door. The stories wouldn't be about beings from impossible distances, but about survivors from a world that was literally visible in Earth's sky every morning and evening. The cultural impact of such arrivals would have been profound and lasting. Think about how human societies remember traumatic events. They become embedded in our deepest myths and stories. The arrival of beings from a dying world would have been exactly the kind of transformative event that gets preserved in cultural memory for thousands of generations. But here's what makes this even more intriguing. If Venusian refugees really did reach Earth, they would have brought with them not just advanced knowledge, but also the psychological weight of being the last survivors of an entire world. Imagine carrying that burden, being among the final representatives of civilizations that had existed for millions of years, knowing that everything your species had ever built was now buried under toxic clouds and crushing heat. This trauma would have shaped everything about how they interacted with their new world. They would have been simultaneously grateful for Earth's hospitability and terrified of making the same mistakes that destroyed Venus. Their approach to technology and environmental management would have been informed by the ultimate cautionary tale. They had literally watched an entire planet die. Any knowledge they shared with early Earth life would have come with warnings, stories about the importance of atmospheric balance, the dangers of runaway climate change, the fragility of planetary habitability. These lessons, passed down through countless generations, might have evolved into the environmental wisdom traditions we find in cultures around the world. But the biological impact could have been even more significant than the cultural one. If these refugees carried with them genetic material from Venus, either as part of their own biology or as preserved samples from their dying world, then Earth's evolutionary trajectory could have been fundamentally altered. Modern genetics is revealing that life on Earth has experienced several periods of rapid diversification and complexity increase, events that seem to happen too quickly to be explained by gradual natural selection alone. The introduction of advanced genetic material from a planet where evolution had been operating millions of years longer could explain some of these sudden leaps in biological sophistication. We might literally carry Venusian DNA in our cells without knowing it. The genetic code that defines every living thing on Earth could be a hybrid, part terrestrial evolution, part inheritance from a planet that no longer exists in any habitable form. Our intelligence, our creativity, our drive to explore and understand the universe could all be echoes of minds that first evolved under alien skies. This possibility reframes everything about human nature and our relationship with the cosmos. We often wonder why humans seem so driven to explore space, why we're so fascinated by other worlds, why we feel this deep urge to spread life beyond Earth. What if these impulses aren't just curiosity? What if they're genetic memories of a species that once had to flee their dying planet to survive? The implications ripple outward in fascinating directions. If Venus really was the first home of intelligence in our solar system, then Earth becomes not the origin point of consciousness, but its sanctuary. We're not the first chapter in the story of awareness in our cosmic neighborhood. We're the continuation of a story that began elsewhere and survived against impossible odds. This would mean that every human achievement, every work of art, every scientific discovery, every moment of love and creativity carries within it the legacy of worlds and beings we can never directly know. We are the flowering of seeds planted by civilizations that watched their planet die and chose to ensure that intelligence would continue somewhere else. But perhaps the most profound implication is what this tells us about the nature of intelligence and civilization in the universe. If the Venus hypothesis is correct, then consciousness isn't rare because it never develops. It's rare because it's fragile. Civilizations might arise regularly throughout the cosmos, but they face existential challenges that most cannot survive. The silence we encounter when we look for signs of other intelligent life might not be because intelligence is uncommon. It might be because most civilizations, like the hypothetical ones on Venus, eventually face environmental catastrophes that wipe them out completely. The universe could be filled with the ghosts of dead worlds, planets that once hosted thriving societies now reduced to toxic wastelands or frozen rocks. In this view, Earth isn't special because it's the only world that developed life. Earth is special because it's one of the few worlds where intelligence has managed to survive long enough to become aware of its own cosmic context. We exist in a brief window between the silence of dead worlds and the silence that might eventually claim us too. This perspective makes our current moment in history absolutely critical. If we really are carrying forward the legacy of Venus, then we also carry the responsibility of learning from their failure. We have the chance to be the first civilization in our solar system's history to recognize planetary environmental threats before they become irreversible. The climate crisis we're facing isn't just about preserving human civilization. It's about ensuring that the chain of consciousness that began on Venus and continued on Earth doesn't end with us. If we fail, if Earth goes the way of Venus, then millions of years of evolution and cultural development across two planets could be lost forever. But there's also hope in this story. If Venusian civilizations really did manage to preserve some part of themselves by seeding Earth with life, then they prove that intelligence can survive planetary death. Not in its original form, but as a continuing thread of awareness that adapts to new worlds and new conditions. This suggests that consciousness itself might be more resilient than we think. Even if civilizations fall and planets die, the spark of awareness can find ways to continue. Life, intelligence, and culture might be tougher and more adaptable than the worlds that host them. The Venus hypothesis forces us to think about civilization on timescales that dwarf human history. Our entire recorded history spans maybe 10,000 years. The rise and fall of hypothetical Venusian civilizations would have unfolded over millions of years. In that context, our current challenges, climate change, environmental degradation, resource depletion, are just brief episodes in a much longer story of intelligence learning to survive in a universe that's often hostile to consciousness. If we can learn from Venus's cautionary tale, if we can develop the wisdom to manage our planet system sustainably, then we might be the first civilization in our solar system to break the cycle. Instead of facing extinction when our world becomes uninhabitable, we might become the first to develop true mastery over planetary environments. We could be the ones who finally solve the puzzle that destroyed Venus: how to maintain a stable, life-supporting planet indefinitely. And if we succeed, we might eventually become the ones helping other worlds avoid the same fate, spreading not just life, but wisdom throughout the galaxy. The story of Venus, real or imagined, teaches us that planets are temporary, but consciousness can endure. Worlds die, but awareness finds a way to continue. And if we're carrying forward the legacy of an ancient civilization that refused to let their destruction be the end of intelligence in our solar system, then we owe it to them and to the future to ensure that their sacrifice wasn't in vain. But what if we're looking at this all wrong? What if the most incredible part of the Venus story isn't about ancient civilizations that died out millions of years ago, but about what their legacy might mean for us right now, today, in this moment? Because here's the thing that keeps me awake at night thinking about this. If Venus really was home to advanced civilizations, and if they really did seed Earth with the building blocks of life before their world became uninhabitable, then we're not just random accidents floating on a rock in space. We're the inheritors of the greatest rescue mission in planetary history. Think about what that means for human psychology and behavior. Why are we so obsessed with space exploration? Why do we feel this deep, almost genetic compulsion to spread beyond Earth? Most species are perfectly content staying in their ecological niche. But humans have this relentless drive to push boundaries, to explore new frontiers, to establish backup plans on other worlds. What if that drive isn't just curiosity or ambition? What if it's encoded in our very DNA, a survival instinct inherited from beings who literally had to flee their dying planet to preserve intelligence in the universe? We might be carrying forward behavioral patterns that evolved under the pressure of planetary extinction. Patterns that kept our hypothetical Venusian ancestors alive long enough to give consciousness a second chance. This could explain so much about human nature that seems inexplicable otherwise. Our tendency to worry about long-term threats that won't affect us personally. Our ability to cooperate on massive scales to solve problems that span generations. Our willingness to sacrifice immediate comfort for abstract future benefits. These aren't typical animal behaviors. They're the kind of thinking you'd expect from a species that evolved from survivors of planetary catastrophe. But let's dig deeper into what this means for our current situation. If the Venus hypothesis is correct, then climate change isn't just another environmental challenge we need to solve. It's literally history repeating itself. We're watching the same process that destroyed Venus beginning to unfold on Earth, and we have a choice to make. We can be the first intelligent species in our solar system to recognize the warning signs early enough to do something about them. Or we can become the second civilization to watch helplessly as runaway greenhouse effects transform our world into an uninhabitable hellscape. The parallels are genuinely terrifying when you look at them closely. Venus's death spiral began when atmospheric carbon dioxide levels rose beyond the planet's ability to naturally regulate them. Sound familiar? We're currently pumping CO2 into Earth's atmosphere at rates that are orders of magnitude faster than anything in the geological record. We're conducting the same experiment that killed Venus, just on a different world. But here's where it gets really interesting. If Venusian civilizations really existed, they would have had access to technologies and scientific understanding that we're only beginning to develop. They might have tried every solution we're currently considering: renewable energy, atmospheric engineering, massive reforestation projects, even space-based solar collectors. And it still wasn't enough to save their world. Does that mean we're doomed to repeat their failure? Not necessarily, because we have advantages they didn't have. We know their story, even if only in speculative form. We understand the end result of planetary climate breakdown. Most importantly, we're catching the problem earlier in the process. Venus's transformation unfolded over millions of years. By the time any hypothetical Venusian scientist realized what was happening, the feedback loops were already too advanced to stop. We're identifying the same warning signs while we still have time to act. The question is whether we'll have the wisdom and determination to actually do it. This brings us to one of the most profound implications of the Venus hypothesis. If consciousness really is rare and fragile in the universe, if most civilizations eventually face extinction-level environmental crises, then our current moment might be the most important in cosmic history. We could be standing at the fork in the road that determines whether intelligence survives in our solar system or goes extinct completely. That's an almost incomprehensible level of responsibility. Every decision we make about energy policy, environmental protection, and technological development isn't just affecting human welfare. It's potentially determining whether the chain of consciousness that stretches back to Venus continues or ends with us. But let's explore what success might look like. What if we actually learn from Venus's cautionary tale? What if we become the first civilization to develop true mastery over planetary climate systems? The technologies we'd need to develop would be staggering in their sophistication and power. We'd need to understand atmospheric chemistry at levels that make our current climate models look primitive. We'd have to engineer biological systems that could actively manage carbon cycles on a planetary scale. We might even need to develop space-based infrastructure that could regulate the amount of solar energy reaching Earth's surface. Imagine atmospheric processors that could fine-tune the chemical composition of our air with the precision of a laboratory. Picture engineered organisms designed to absorb excess carbon dioxide and convert it into useful materials. Envision orbital mirrors or shades that could adjust Earth's temperature by controlling how much sunlight reaches the surface. These aren't fantasy technologies. They're logical extensions of scientific principles we already understand. The challenge isn't whether such systems are theoretically possible, but whether we can develop them quickly enough and deploy them at sufficient scale to prevent runaway climate change. And here's the beautiful part. If we succeed, we don't just save ourselves. We become the species that finally solved the puzzle that's been destroying worlds throughout cosmic history. We'd be the first to prove that intelligence can not only survive planetary environmental crises, but actually gain mastery over them. That knowledge would be incredibly valuable for the future of consciousness in the universe. As we eventually spread to other worlds, and if we solve the climate crisis, we almost certainly will spread to other worlds. We'll carry with us the wisdom needed to establish sustainable civilizations anywhere. We could become the gardeners of the galaxy, helping to establish and maintain habitable conditions on planets throughout our local stellar neighborhood. Instead of being refugees fleeing from one dying world to the next, we could be the species that ensures no world ever has to die from environmental collapse again. But this vision of the future depends entirely on what we do right now. And that's where the Venus story becomes not just fascinating speculation, but urgent practical guidance for our current choices. If hypothetical Venusian civilizations really did watch their planet slowly transform into a hellscape, they would have gone through every stage of climate crisis response that we're experiencing today. They would have had their deniers insisting the changes were natural. They would have had their politicians arguing that economic concerns outweighed environmental ones. They would have had their technological optimists claiming that innovation would solve everything without requiring lifestyle changes. They would have experienced all the psychological and social barriers that make climate action so difficult. The tendency to focus on short-term problems while ignoring long-term threats. The challenge of coordinating global responses to planetary scale problems. The difficulty of making sacrifices today for benefits that won't be fully realized for generations. But they would also have learned which approaches actually work and which ones don't. If we could somehow access their accumulated wisdom about managing planetary environments, we might be able to skip decades or centuries of trial and error. Of course, we don't have direct access to Venusian knowledge, but we do have something almost as valuable: the ability to study what happened to their planet and learn from the end result. Venus is like a massive controlled experiment in planetary climate breakdown. We can analyze the final conditions and work backward to understand the processes that created them. Modern space missions to Venus aren't just about satisfying scientific curiosity. They're potentially gathering intelligence about the most important challenge our species has ever faced. Every measurement of Venus's atmospheric composition, every analysis of its surface geology, every computer model of its climate history gives us clues about what to avoid on Earth. In a very real sense, Venus is our early warning system. It shows us exactly what runaway greenhouse effects look like in their final stages. The crushing atmospheric pressure, the toxic clouds, the surface temperatures hot enough to melt metal. These aren't just interesting facts about another planet. They're previews of Earth's potential future if we don't change course. But Venus also shows us something else: the incredible resilience of planetary processes. Even after billions of years in its current state, Venus still maintains complex atmospheric dynamics. Its geology remains active. The planet itself survives, even if it can no longer support life as we know it. This suggests that if we do fail to prevent climate breakdown on Earth, it wouldn't mean the end of our planet, just the end of its habitability for current life forms. Earth would continue to exist, potentially for billions more years, waiting for conditions to eventually change again. That's both terrifying and oddly comforting. Terrifying because it means planetary death is a real possibility that we need to take seriously. Comforting because it suggests that even worst-case scenarios aren't necessarily permanent on geological timescales. But geological timescales are much longer than the timescales of civilization. If Earth goes through a Venus-like transformation, human civilization wouldn't survive to see the planet recover. We'd be just another extinct species in the fossil record, assuming anyone was left to read that record. This brings us back to the central question of the Venus hypothesis. Are we alone in facing these challenges, or are we part of a cosmic pattern of civilizations rising and falling based on their ability to manage planetary environments? If consciousness is common in the universe, but environmental mastery is rare, then most civilizations probably face extinction before they develop the wisdom and technology needed for long-term survival. The universe could be littered with dead worlds that once hosted thriving societies, planets that fell victim to the same kinds of environmental feedback loops that destroyed Venus. In this view, the great silence we encounter when we search for signs of other intelligent life isn't because consciousness never develops. It's because most conscious species don't survive their adolescent phase, the period when they develop enough technology to affect their planetary environment, but not enough wisdom to manage those effects sustainably. So here we stand at the crossroads of cosmic history, carrying within us the potential legacy of a world that died so we could live. Whether Venus actually hosted ancient civilizations or not, the story it tells us is crystal clear. Planets are fragile. Consciousness is precious. And the window for survival is narrower than we ever imagined. We might be the universe's second attempt at intelligence in our solar system, inheritors of a chain of awareness that stretches back billions of years. The question now isn't whether we're alone. It's whether we'll be wise enough to break the cycle of planetary destruction and become the first civilization to truly master our world's climate. The next few decades will determine if Earth follows Venus into silence, or if we finally prove that intelligence can triumph over the forces that have been destroying worlds since the cosmos began. The